Okay, so logarithms is something that is in the standards for Algebra 2, but it's towards the end. So I know because of everything that happened last year, you guys didn't get to logarithms. So that's what we're going to start with this year. So a logarithm is not scary, I promise. You've probably seen it on the ACT and not known what it is, but it's more simple than probably what you think. So a logarithm is just a special way to ask a specific question. What a logarithm looks like is this: log base b of a equals x. So the b is a subscript. It should be smaller and lower than all the other letters. Just the L. I mean, it can all be in cursive. I don't care. Anybody need a pencil? You got it. Everyone should be taking notes. Okay, the way that you read a logarithm is like this: log base b of a equals x.
So is the b little?
Yeah.
And the a is normal?
Yeah.
Or is the a big?
Though it's like this. You guys remember these, like when you were learning how to write your letters in kindergarten?
Yeah.
It's like this. Everything is the same size except for the b, because it's the base. So you read it: log base b of a equals x. And b and a and even x are just placeholders for numbers, basically. So the question that a logarithm asks is, what exponent needs to be placed on b to reach a value of a? So we're going to look more at this question when we get to the other side of this page. I want to first look at the difference between exponential form and logarithmic form. You can switch back and forth between these two really easily because they have the same 3 parts in each. They're just in different spots. So in an exponential equation, you have a base with an exponent. So when you raise a base to an exponent, you end up with some number. Those same 3 parts, when you write it in logarithmic form, is this: log base number equals exponent.
And we're supposed to be writing it just like that, right?
Mm-hmm.
Like some of them.
Yeah, the base, yeah, and then all right, this is going to come back into play also when we're trying to change between the 2 forms. But right now we're going to look at evaluating logarithms, or calculating the value of logarithms, this section here. Okay, so the first logarithm we have is log base 4 of 64. Now, we said a logarithm is just a special way to ask a question. Well, the question that this logarithm is asking is 4 to what power equals 64. So what exponent do we need to put on 4 in order to make it equal 64? Okay, the easiest way to find this for now is to just do trial and error. Yeah, I believe 3 is correct. You can see that a little better. Yeah, so the easiest way is just to take 4 and try different exponents on it. I usually start with 2 and just work my way up until I get it. So if you were to do 4 squared, you would see that that is not 64. So then you try 4 cubed, that is 64. So the exponent needs to be 3. So the answer to this logarithm then is 3. All right, let's look at the next one. Log base 6 of 16. This logarithm is asking 6 to what power equals 216. So if you don't already have a calculator out, you need to get one out either on your Chromebook. If your phone has the capability of doing exponents, then that's fine too. But you guys need to be trying this along with me so that you can get the system down. Okay, so you're going to try different exponents on 6 until you get 216. We want to know what our exponent needs to be. Anybody have it yet? Three. So the value of this logarithm is 3 because 6 cubed equals 216. Okay, log base 4 of 16. This is asking 4 to what power equals 16. Hopefully you don't need a calculator for this one. 2. So the value of this logarithm is 2. Okay, the next one's a little bit fun. When a math teacher says that, you know that it's more complicated, right? But only by a little bit. Log base 3 of 1 over 243. So this logarithm is asking 3 to what power equals 1 over 243. So we're raising a whole number to a power and then ending up with a number that's less than 1, a fraction. How's that possible? Any guesses on what our exponent might look like? Our exponent is going to be negative. So there's a couple different ways that you can do trial and error on this one. What is it, 3? Yeah. So you can raise 3 to different negative exponents starting at -2 and then -3, -4, -5, and so on. But that's a little bit complicated because when you raise a number to a negative exponent, which by the way, if you're raising it to a negative exponent, you have to actually use this negative button on your calculator down next to the decimal point. You can't use the minus sign or it'll give you an error. So use that negative sign. Yeah. So if you do 3 to the -2, I get this decimal. So I have to change this to a fraction, math fraction, to see if it's 1 over 243, and it's not. So then I try 3 to the -3rd power. Change that to a fraction. That's not it. 3 to the -4th power. Change that to a fraction. That's not it. And 3 to the -5th power. Change that to a fraction. That finally gets it. So So our exponent needs to be -5. So that means the answer to this logarithm is -5. Now, the other way to do trial and error on this one, in which in my opinion it's easier, is just to ignore the fact that this is a fraction and see what exponent on 3 gets you 243. So you would just have to try 3 squared, no, 3 cubed, no, 3 to the 4th, no, 3 to the 5th, that's it. But then you just have to know, the calculator's not going to tell you this because they don't know that it's a fraction. You just have to remember that because it's a fraction, I have to make that 5 negative. So whichever one of those ways that you want to do it is fine. Any questions so far? Not too bad? Okay, I want to skip down to this one because it's another kind of different one. Log base 343 of 7. Okay, so this logarithm is asking 343 to what power equals 7. So the one that we just worked, we raised a whole number to a power and ended up with a number less than 1. Now we're raising a whole number to a power and we're ending up with a smaller whole number. Any ideas what our exponent will look like this time? A fraction. So again, there's a couple different ways that you can do trial and error on this one. The first way is to try different fractions as your exponents. So if I want to raise 343 to the 1/2 power, which you can just enter 1 divided by 2 to get 1/2 up there. And that's not 7. So I do 343 to the 1/3 power. That gets it. If it wasn't 1/3, you would move on and do 1/4 to 1/5, 1/6, and so on. But 1/3 got it. So we know our exponent needs to be 1/3, which means the answer to this logarithm is 1/3. Okay, the other way that you could do trial and error on this one is by thinking of it as it being backwards, like 7 to what power equals 343. So try different exponents on 7 until you get 343. 7 cubed is 343. So we know 3 is the number that I need, but because we did it kind of backwards, we know that our exponent needs to be a fraction, and that fraction is going to be 1/3. Again, whichever way is easiest for you on that one, that's how you should do it. Okay, there's 5 left that we haven't done in this section. I want you guys to do those on your own and then check your answers with someone next to you before I work through them and we'll talk about it. Okay, I'm gonna start working through these. If you're not finished, you can just follow along. So looking at log base 5 of 125, this logarithm is asking 5 to what power equals 125. So what exponent needs to go on 5 to make it equal 125? 3. So that means the answer to this logarithm is 3. Okay, probably the easiest one on the page, log base 2 of 4. 2 to what power equals 4? What'd you get? 2. So the value of this logarithm is 2. Okay, log base 2 of 16. This is asking 2 to what power equals 16? 4. So the value of this logarithm is 4. Okay, log base 64 of 4. This is asking 64 to what power equals 4. So this is one of the ones where we have a whole number and we're raising it to a power and we end up with a smaller whole number, just like the one above it. So your exponent should be a fraction. What did you guys get? 1/3.
I did 1/3 and I got like freaking 5 point blah 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 blah.
What?
I had that problem too.
I got like 5 point, you got a bunch of numbers that I don't know what they mean. You'll hit like the math and then.
But it shouldn't be 5 point something. Did you try?
Actually, mine was like 3 point something.
So actually what I did was wait, is it a negative fraction?
No.
Okay, well, never mind.
What did you put in, Lulu? I want to try it.
I'd rather not share.
What did you put in, Chris?
I put in, I was thinking if I put in like a negative exponent, I might get something different. I came close, but it was wrong.
Yeah, no, it's either going to be a negative exponent if you have one like this next one that we're going to do, or it's going to be a fraction. It shouldn't ever be a negative fraction.
Thank you.
You're welcome. Okay, log base 6 of 1/216 is asking 6 to what power equals 1/216? -3. Good. So the value of this logarithm is -3. Any questions on this section? All right, let's look at the next section, which is converting between exponential and logarithmic form.
And this is just the same thing in a different one, right?
Yes, yeah, where you're switching the, different orders. Okay, so this is where what we wrote on the front page is going to come in handy, because both exponential and logarithmic form have the same parts. They're just written in a different order. So we are going to be the ones to be switching from exponential to log form or from log to exponential form. Okay. So this first one, 1/5 to the x power equals y. This is in exponential form, so we want to change it to logarithmic form. That means the very first thing that we have to write is log. And yes, I would prefer that you get into the habit of using a cursive L. You can write the whole thing in cursive if you want to, but at least the cursive L, because if you don't, then this log that you write could end up looking like 10g, which is a number with a variable instead of the log function. So just try to get into the habit of using the cursive L. Trade you. I'm sure it's fine. Okay, so we wrote log. Now the base of our exponential function, which is the number that has the exponent on it, is going to be the same for our logarithm. So 1/5 is still our base. So it gets written as a subscript. Make sure everyone is keeping notes, keep up. Okay, the next thing we're going to write is y. And then remember, the answer to a logarithm is an exponent. So whatever is in the exponent in an exponential equation becomes our answer to the logarithm. So it gets written on the other side of the equal sign. Okay, let's look at changing this logarithm into exponential form. Log base u of 15/16 equals v. So u is our base. V, which is the answer to this logarithm, becomes our exponent. And then that equals 15/16. Okay, before we move on, I'm going to show you guys a trick to help you remember what goes where when you're doing this. So if you'll find just a blank part of your notes page, I'm going to show you what's called the loop trick. So the loop trick is something that's going to help you convert from logarithmic form to exponential form or vice versa. So let's say we have a logarithm, log base b of a equals x. And we want to change this to exponential form. So we're going to draw a loop starting at the base, which is the subscript b in this case, and we're going to draw a counterclockwise loop around to a. Hence the name, the loop trick. Okay, all this loop is going to do is help us know which order to write these three parts. So if we follow our loop, we're going to write b first. Follow the loop around, we'll write x second. And then the last thing we'll write is a. So when we write this in exponential form, first of all, we don't write log because we're changing it out of log form. We just follow our loop. So we write b first, then we write x as our exponent, and that equals a, bxa. Okay, the loop trick also works if you're changing from exponential form to log form. So let's say we start with b to the x power equals a. And we want to change this to logarithmic form. So again, we're going to start at the base, which is the number or letter that has the exponent on it, in this case b, and we're going to draw a counterclockwise loop around to the exponent. Okay, so when we write this in log form, we're going to write b first, then a, then x. It's just, you won't normally do that. It's just me showing you what order you're going to write these in.
Wait, never mind. They're just going to keep it in mind.
Okay, so when we write this in log form, the very first thing you have to write is log. Then you can follow the loop. Base b of a equals x. Okay, so let's use this loop trick to do the next couple conversions on our paper. Okay, so let's look at 9 to the y power equals x. If we want to use the loop trick to change this to log form, we start at the base, which is 9, and draw a counterclockwise loop around to y. So when we write this in log form, we'll write the 9 first, then we'll write the x, then we'll write the y, in that order. Okay, so the very first thing we have to write is log, because we're trying to change this to log form. Then we can follow our loop. So our base is 9, then x equals y. So eventually, once you get more and more used to this, you won't have to write these numbers to remind you what order to write the parts in. You may eventually get to where you don't even have to draw the loop and you just know in your mind to follow the loop. So all of that is just scratch work. You don't have to do that on your paper if you don't want to. It's just a way to help you remember what order to write them if you've forgotten.
So I have a question.
Yeah.
For like the fractions, do we have to put those in parentheses?
Yeah, I would prefer them unless it's just like out here by itself, like 15/16 was. But like this next one, log base 7/4 of x equals y. We're going to change this to exponential form. And if you want to use the loop trick, you start at the base, which is 7/4. Draw our counterclockwise loop. And we're changing this out of log form, so there's no reason to write log this time. We just follow our loop. 7/4, and yes, because it's a fraction, I would prefer that you put it in parentheses. 7/4 raised to the y power equals x. Yeah, it's never going to hurt to put parentheses, but on something like this, it could hurt if you didn't. For example, if you did 7/4 raised to the y power, it looks like that y is just being applied to the 7, when really it should be being applied to the whole fraction. So, any questions on converting between the two forms before y'all do the rest of these? Okay, there's 8 left on this page. So I want you guys to do those on your own. Check your answers with someone next to you. And then I'll write the answers in a minute to make sure you got those. Okay, I'm gonna go ahead and write them up here. So check your paper as I go.
My nephew's cold.
Hey, that's better. Anybody have questions on these? Good. Just waiting for the shoe to drop. Okay, so these are your notes. You're gonna hold on to those, and then I'm about to pass out some practice problems for you to work on. Uh-huh. Yeah. And then you guys on Zoom, as soon as I get these handed out, I will post it onto Google Classroom for you guys.